Okay, well this video is for my own purpose, just to remind me what I've done on a part of my 8-bit computer build. This is a bank of 4 general purpose registers, and I wanted to sort of highlight how the wiring was done and my plans and intentions for some of the control logic which are going to control the use of these registers for each and the type of opcodes that I could have. Okay, so if we just take a look at the board, I'll just explain what they are, what the components are. Octal 245 transceiver 4574, and I'll show you the data sheet for that in a second. 574 8-bit registers, 8 bits, not 4-bit. And then a final transceiver here. This one's enabled direction 1, always going from left to right. This one, the first one, this is going to be connected to the bus, the shared bus. It's unique in that, unique from other designs I've seen anyway, that I'm making use of the direction line. I'm going to be setting the direction to 1 or 0 depending on what you plan to do with it. So if you plan to write to these registers here, to one of these registers, or more than one in fact, you would set the direction to be 1, it's going that way, and you would then latch particular lines, the clock lines, to allow data to be written to these registers. If you want to present the registers on the bus, then obviously this direction line will be 0 and the data will be coming out, and you would make sure only one of these registers was enabled, and that is done with this MUX here. This is an LS139 2-bit to 4-line MUX, selected with these 3 pins here. 2 pins are the 2 bits, 0, 1 or 2, 0, 1, 2 or 3, I beg your pardon, binary, and the top bit is for selecting that register. So if you wanted to disable, if you just wanted the bus to, if you didn't want any of these registers on here, if you wanted to write to one of these registers, then obviously that bit there would make sure that none of these chips were enabled. I think that bit there is connected to G2. I'm only using 1/2. There's two muxes in here. I'm only using 1/2. So this particular top, this top one here is connected to G2, and that's active low. So that would be high to make sure that none of these chips was presented on this bus, this part of the bus here. And you would probably strobe one of the clock lines, or more than one of the clock lines. You can strobe all 4 if you wanted to write to the registers. So we'd write data from what's on the bus to the register that's being strobed, register or registers that are being strobed. I'm planning to add some extra logic into this writing mechanism, these 4 lines here. I'm planning to add in an odd number of inverters to produce some kind of delay. The reason for doing that is to try and see whether I can write register data and from a bus in one, and present data as well from a particular register. I want to be able to present data from one register and write to one or more others. So in theory, I should be able to present register 0 on this particular this bus inside here, and then strobe these 3 lines all in the same clock cycle. And I'm, by introducing the a delay by using an odd number of inverters, then I should be able to do that. I haven't tried it, but I'm hopeful. Now to go to this data sheet about the to go over to this data sheet about the 8-bit register. If you look at the wiring, this is the 574, the one I'm using. If you look at the wiring, yes, it's got 8 bits. That's nice. The only gotcha is it's got no clear. But ignoring that, if you look at the wiring, you can see on each row the input is opposite the output. And that, if you're working on Veriboard or PCB, you're not going to get this benefit if you're on breadboards. If you're working on Veriboards, it's very simple to wire up. If I go back to the Veriboard and turn this round and show you the wiring at the back here. That's the transceiver. That's the transceiver. But look at the wiring or the breaks for the register. All I'm putting breaks on are the ground and the latch, the clock, and the VCC and output enabled. The data is presented along the whole of this bus here up to this endpoint here. Of course, actually, because this is always on, it's going over to here. So, you know, I can present the data for what's on the bus to all registers and strobe a particular line, the clock line, to write to that register. Or I can set the direction to 0 and present a register, only one register, obviously, onto the bus. Very, very simple. What I plan for this side, by the way, is to have a hexadecimal display presenting you with data that's on the bus or data for a particular register. And I would have LEDs here showing which register, if any, is being presented on the bus. So that's it. Pretty cool, I thought. And I wanted to make sure I sort of captured on video what I've been doing, because I know in a few months' time I'll forget all about this. Okay, thank you. Bye-bye.